Music is just a series of altered patterns. The musician creates the pattern and makes us anticipate resolution, and holds back, makes you wait for it. There's patterns in everything and everyone.
You're listening to Guy Rollers.
Good evening, folks. Can you hear me? Can you hear me loud and clear? And can you hear me over the top of the music? I know I seem to have this problem at the start. So I'm hoping that you can still hear the backing music nicely, but the voice is clear enough and doesn't get drowned out. Yes and yes. Fantastic. Man, so we're actually on time. And technology appears to be working. That's a good thing, but it's a bad thing because usually there's a mistake somewhere, which means that's bad news. You can't hear music at all, Sasha. That's interesting. If I bumped up the volume slightly, would that ruin it? What if I did this? How's that? I'm actually a pretty big fan of this restream thing and having the restream bot in there because all the people across the different platforms are able to talk, and that's awesome. Okay, well, I'm going to continue talking and assuming that everything's fine. So let us begin. Let us begin. Okay, let's flip off my... I have no idea what I'm doing. Sounds good. Okay, so good evening all. I have a jumper on because I'm cold. Yes, it is possible to get cold in Queensland. Deal with it, particularly those poor buggers that are down in Melbourne where it's freezing. I'm looking at you, Justin. Hey, Zorcat, thanks for coming along, buddy. So, cheers to all the crew for rocking up. As always, step one, I like to plug Guy Baroni. You'll see his SoundCloud link on screen right now. This is the music that I'm streaming, although I'm streaming it on my desktop host, not inside the VM. This is the music that you can hear in the background. I really, really like it. It's fantastic. So thanks to Guy for letting me stream his music as backing track. I just think it's really cruisy, easy music, and it's nice to have something playing in the background. So many thanks to that guy. So one thing I am going to do as well is quick shout out to a number of people who have recently supported me on Patreon. It's very, very flattering and humbling to see the people who are pitching in and what they're pitching in. So much love to all of you for that. It's really, really flattering and humbling. Thank you very much. Okay, so I've just been hosted by Rally. Thank you very much. That's awesome. Love your work. Right, so remember we're technically not hacking this evening. We're fixing things for hacking. Who we got? Moonmaster. I don't think I recognise your name, but greetings. I hope all is well at your end. So we're not hacking, but even though we're not hacking, whatever it is that we're doing without tea is uncivilized. So make sure that you have a nice cup of tea. Tonight's brew is not the sort of semi-regular Gayakuro from T2. This is the straight black Assam tea from T2. I felt like something a bit heavier. Plus, I've actually only just finished a litre of Gayakuro about an hour and a half ago. So we've got Stealth back again. Greetings, Stealth. Okay, so tea. Now I also ran out of the 90% lint. So this evening's chocolate, as we know, has to be some kind of dark organic, is this Pico. It's only 85%, so it's slightly sweeter, but this is pretty good stuff. It's a fantastic fallback for cases where you can't get a 90 or higher. So, love this stuff. It's fantastic. Righto, so the plan for tonight, we're not actually going to be doing any hacking, but we're going to be fixing a bug in a well-known hacking tool. How come you have horns? Well, I always have horns. I assume you're pointing at, referring to my hair. It's because I don't care about doing my hair. Little Master, following your YouTube for a while, couldn't make it to your stream up to now. Awesome, man. So good to have you. Thanks very much. That's fantastic. Sasha, yes, I've got a little bit of milk in the tea, although I think I might have over milked very slightly, but it's still a good brew because the tea is still quite strong. I like to put a tiny bit of milk usually in my black tea just to remove that slight bit of bitterness, but it's not usually that milky, I'll admit. Okay, so the plan tonight, in fact I should bring this up as .com. I'm going to go to me, and then I'm going to click on the series of links that will take me back to the GitHub issue. Okay, so I was chatting behind the scenes via DM to Zigzag, or Aconite as he's known. I actually don't know this person's real name, but I know them as Aconite. And we were talking about this problem here. Named pipe pivoting in Meterpreter and how that worked, and he was having some issues with it. And I recall this bug being logged quite a while ago, and he brought it up and said, oh, okay, so everything seems to be working fine when you're pivoting your session back through a reverse TCP transport as compared to an HTTP or HTTPS transport. So overmilked is better than undermilked. That's probably true. Okay, so for those who aren't aware, Meterpreter Metasploit now has the ability to pivot through named pipes. So there's two different scenarios in which this is working. There's a bind named pipe handler, which makes use of sockets going through existing sessions to connect to a session that's listening on a named pipe, and there's a transport that works in that regard. The one that we're talking about here is a reverse named pipe. So the way this works is a little bit different to the standard payloads and handling, because instead of having your listener on the attacker side, on the Metasploit side, you have a session somewhere on a network already in the middle, and then you need to be able to connect to this one in the middle from a new session and pivot through that session and back out to the Metasploit listener. And the way that that works as well is it uses something that we called packet pivoting. So we weren't sort of opening up channels. And for those who aren't familiar with a channel, inside Metasploit, the concept of a channel is basically like a tunneled stream of data. Now that can come from say a socket that's being listened to. It can come from an application like a shell or something like that that's open, and we're just sort of streaming that data. Now that works fairly well, and that's how port forwarded sockets and things like that actually work. So that all works. The problem with that is that there's quite a bit of overhead. For every bit of information that's sort of piped through this channel mechanism, there are TLV packets and all kinds of other metadata that wrap it up before it's sent down the wire. So what I wanted to do with this notion of packet pivoting, knowing full well that the information that was coming from this end session could just be passed straight on to the handler, I had to do some work that would allow that packet to come in on the named pipe, and then for that named pipe listener to read the packet and put it on its own transport and funnel it back down to Metasploit. And then Metasploit could respond to that, and locally that man in the middle session, so to speak, could look at some metadata of that return packet and go, oh, that's not mine, that's for that transport over there. So it sort of just pivots the packets across its own transport without actually wrapping them up in any of its own packets or metadata. So that's basically the way the mechanism was designed to work. What do we got? There's quite a bit of discussion tonight. That's fantastic. Oh, Rook Inversex now hosting me too. That's awesome. Thank you, sir. Stealth. Hitting something odd in current user PXX doesn't seem to resolve the host names. Yeah, that's not surprising, Stealth. I don't think any host name resolution happens across existing sessions. That's something that would be really nice to be able to enable, but I don't even know that that's being discussed. That's perhaps something that we can have a chat to the powers that be about. So we have another listener on YouTube. Greetings, sir. Thank you for joining. Did we discuss the climbing results first? No. And I won't do that until the end. If people are interested in climbing results, we'll talk about that at the end. Hey, Jay. Thanks for coming in, dude. Greetings, Splat. Nice to see you, mate. Oh, it is. Stealth. Oh, it's done in the PR of the module. Really? Okay. Well, maybe if and when we get this done tonight, assuming that we're able to locate and fix the issue, maybe we can have a quick look at that to see what the story is. There is clearly the ability to resolve host names behind the scenes, so yeah, maybe it's attending to use the existing hostname resolution functionality and then ultimately not utilizing itself. So yeah, maybe we can have a look at that as well. Anyway, so excuse me, back to packet pivoting. Now, this bug here, as you can see, it's basically saying that when the session in the middle is using a TCP transport to talk to Metasploit, everything works fine. The packet pivoting works and the sessions are happy talking to each other. But when the transport that's between the two sessions is reverse HTTP, I assume HTTP or HTTPS, when that's in place, for some reason, it doesn't work. And thankfully, whoever this person is, Manduk4, has sort of highlighted that, you know, it looks like a null pointer dereference or something in here. Here you go, RCX is 0. So clearly there's something going on in the case of pivoting packets over HTTP that's causing it to break. And this is particularly frustrating for me because it is the kind of stuff that I tested pretty rigorously before I did the original PR. But as we know, nobody's perfect. I write shit code, sorry. And I'm going to fix my shit code with the potential to add more shit code in the process. But hey, we learn just as much from looking at shit code as we do looking at non-shit code. Oh, it's so good. Greetings, is that Caleb? Caleb Wham? Caleb Wham? I'm not sure how to say your name, but greetings, thanks for joining in. The chocolate's good. Okay, so Debugging, the process of replacing old bugs with new bugs. That's so true. So very true. Now I'm going to leave this up so that we can reference it later. Now, I'm just going to quickly explain the setup that I've got going on here. I have two VMs. This is going to be both my development VM, and it's going to be the host for dealing with the packet pivot related stuff. So, Acebond, thanks for coming, dude. Lagging, huh? I've got streams running on different machines and making sure that everything's cool. So if I see any lag at this end, I'm conscious of it, but I'm pretty sure, Caleb, that it might just be your end, mate, but stick with us, stick with us. Okay, so this VM, I'm going to be using it for fixing, building, doing stuff in Visual Studio, and actually executing the payloads and seeing what's going on. Hey, Borgia! Borgia Marino. Wow, I am honored. Ladies and gentlemen, Borgia. Borgia is a legend. It's so flattering to have them rock up and pay attention to my little neck of the internet woods. Thanks a lot for coming in, man. That's fantastic. Borgia's a weapon, people. If you don't follow this guy, you need to. So, yeah, awesome. So excited to see your name come up, man. Thank you. Okay, so we're going to be doing the development and execution and tracking of payloads on this host because this is where the Meterpreter stuff is going to be. Maybe, okay, so I'm seeing that there's people having transcoding issues, but yeah, I don't really know what to say. Maybe, you know, if it continues to be painful, then maybe check out the YouTube thing and force it to a certain level of definition. Maybe go from there. I don't know. Either that or maybe watch the stream after it's been recorded. I'm really sorry, that's a crappy answer, but stick with me if you can. That'd be awesome. Jay, my code is awesome. No, it's really not. It's really not awesome. Anyway, so back to stay on target. So we're going to do all the dev and whatnot related stuff on here, and then on my Fedora machine, this is where I'm going to have the listeners and the attacker. Okay. So to begin with, I'm just going to quickly explain to those people who have never actually done any Metasploit and Meterpreter debugging how I set things up. So first of all, I usually have a resource file, as you can see here. This allows me to generate payloads and set up listeners in a heartbeat. So here you can see I'm just setting some consistent preferences. So my L host points to, as you can see down here on the bottom of the screen, 192.168.20.139. So that's the Fedora VM. Pipe host is actually the IP address of the Win10 machine. So you can see, there you go, 120, 128. So the pipe host refers to what a reverse name pipe payload will connect back to. So we actually want it to connect back to the Windows VM, not the attacker VM, okay? And then there's a pipe name, I'm just giving it something other than the default. And from there, I create a reverse TCP payload, 64-bit, and we're listening on port 4444. We do the same with HTTP, listen on 5555, and I'm also creating a reverse name pipe payload. Now, this is actually important because I haven't tested any of this setup. I just whipped this up. I've got to set something here. Set pipe host. Oh no, hang on. No, I've already done it up here. Set G and set pipe name. I thought, oh crap, I've missed a step in here, but I haven't. Anyway, then I go and create a multi-handler and tell it to not exit when sessions come in. And we're going to set up two listeners, one for the TCP and one for HTTP. So that's all that's going to do, right? And so when I spin this up and point it at the resource file, and as you can see, it should go through and generate a bunch of stuff. There you go. It's one payload, two payloads, setting up the listeners, and as you can see, here are our two listeners. So TCP on 4444 and HTTP. I'm not using HTTPS because if for some reason I feel like looking at the transport going across the wire in Wireshark, then it's clearly not going to be a pain. However, the packets are all encrypted as part of the protocol these days anyway, so it's not going to be easy to look at. But still, we have access to headers and URIs and all that sort of stuff. Okay, so now we've got our listeners up. What I'm going to do is, let's go to this little shortcut. So these 3 executables are the ones that have just been generated, as you can see. 20 past 8 already. I've been babbling for ages. Each one of these payloads is what we're going to be using to execute Meterpreter. Now, each one of these is staged. And the reason why I'm choosing staged payloads is because as we're doing development and we're making changes, we're going to be building new Meterpreter DLLs, deploying them to the attacker box, and then I want to just be able to execute my staged payload again and send the new payload over. If I use stageless, then I have to regenerate bloody payloads all the time, which I really don't want to do. Okay, so if I double click on this and go back over here, we should see we end up with the session. All right. I'm sticking to 64-bit because it's much easier to build for 64-bit and have it pretty much work for 32 out of the box rather than the other way around. So that's basically what I'm doing. OJ, can you please give a brief answer of how PSXEC and WMIC starting remote process works? Yeah, okay, well we can do that, but I'm not going to do it now. Let's talk about that at the end of the stream, okay? But I'm happy to dive into that and maybe ask some specific questions. But what I will say in the short term, as far as PSXEC is concerned, there was a really great video, probably like 2 years ago now, by Dave Maloney, who goes by the name The Light Cosine online. He was working at Rapid7, and he did a really good video that dived fairly deeply into the process of how PSXEC works and whatnot, including, you know, talking to the SC manager and spinning up services and all that sort of thing. So I will dig up at least a link for that for you at the end of the video, and if we have time, we'll dive into that maybe a little bit more together. Okay, so anyway, we've got a functional 64-bit TCP session. Let's make sure that HTTP works as well. Excellent. Look at that. Coffee Addicts comes through with the goods. Boom. Love your work. Thank you very much. That's exactly what I'm talking about. Awesome source. Bind name pipe seems to die for some reason after some minutes. Is that normal? Well, it shouldn't be normal, but I have noticed the same thing, Stealth. So, you know, this is another thing on the to-do list to see why it just starts dying after a while. I don't know whether it's an SMB related thing or not, but hey. Anyway, so we can see that both of our sessions are working. Let's just make sure that we can do something. Yeah. Sysinfo PS. Okay, that works. Sessions -1. Yeah, that works too. Alrighty, so we know that our sessions connect. Now actually what I will do is show you this. Debugging Meterpreter is a real pain in the butt, okay? An absolute pain in the butt. And the easiest way of at least getting visibility of what Meterpreter is doing and whatnot is to enable debug logging and watching what the debug log spits out. So I usually leave debug view running. Now you'll notice when I run a TCP version of the payload as it currently stands, there's no debug output. And that's because, obviously by default, we don't ship DLLs that throw crap loads of debug output. So what we need to do is open up Visual Studio. Okay, open up the Meterpreter project. I've actually just installed VS on this VM because I wanted you guys to be able to see it. So by default, this define here, I should probably check, is this font too small? Justin, is this too small for you? Guys, gals that are watching, is it too small or is it bearable? Just want to make sure that everyone can see what's going on. Might want to bump it up a bit, Rob. Okay, Rob, I will do it just for you. Okay, tools. Options, fonts and colors, text editor. Let's bump it to maybe Lucky 13. How's that? How does that look? I'm guessing that's a bit better. That should be, but we don't want to go too overboard. So I'm going to assume that's okay. Anyway, so this line here, this direct, oh, this one, you can tell that this is a fresh installation. We need to go down to text editor, all languages, and turn on line numbers. There we go. That's better. I hate not having line numbers. So here on line 9, you can see we've got debug trace now enabled. By default, it's actually commented out. If you uncomment it and leave it at 0, you'll end up with like a normal level of debugging information appearing. And if you set it to 1, you get quite an excessive amount. And that varies depending on which transport's in place. So I have actually built this prior to this stream because the original build takes quite a bit of time. But as you can see, down here it's doing all the buildy magicy stuff. Righto, so all of our projects have succeeded. So at this point I need to be able to copy them. Now you see this line here, copy from wherever the payloads are, there's this output folder, and underneath output there's both 64 and 32-bit versions of the DLLs that can be built. Now we're dealing with 64-bit for now, and we'll test the 32-bit at the end. So this is something that many don't know. The Meterpreter payloads are bundled as part of a gem. Okay, so every time we update the Meterpreter payloads, we push a new version of the gem up to Ruby gems, and then when you run bundle update or bundle install, it pulls down the latest version of the gem set, and you end up with new payloads. Now, those people who have been sort of hacking on Meterpreter in the past have searched for the current version of the gem in their Ruby gems folder or something similar, and they've overwritten the existing DLLs. Now, that is actually unnecessary. Inside the Metasploit framework data Meterpreter folder, there are a couple of leftover exes already, but what happens is the code will look in here first to see if it can find a payload, right? And if it's not there, it falls back to the Ruby gem, okay? So if we actually copy those DLLs over, you'll see now we've got all the 64-bit versions of the one that we've just built. In fact, there you go, 25 past 8, so only just built. That basically means now that Metasploit should look for that DLL. Okay, so let's run TCP. Now there you go, you see it's picked it up and there's a bunch of debug output coming out, okay? Now if we come back over here, now this is really, really helpful for those people who are used to doing some work on Meterpreter and having debug DLLs lying around, but forget about them. When you launch Metasploit, when it first touches a DLL in that data Meterpreter folder, you'll get a warning here saying, hey, just so you know, like we've got a debug or a development DLL currently being used. In case you didn't intend that to be so, you should probably go and get rid of it. So every DLL that you touch, it should appear here. So you can see metserv, standard API, and priv. So they're all the debug versions that we've just built. And as you can see, there's plenty of things going on here. All right, now I'm not going to dive into the output of this just for now. But as you can see, there's coverage of how the packet encryption works and how packet pivots are found and what the commands are that a current session happens to have exposed, etc. So, and then when you execute a command, you can see, for example, let's just type getUID. So straight away, we should be able to see, there you go, getUID, command XX. So you can see it locating the base command, standard API sysconfig getUID. So it locates the command handler, executes it on a thread. A bunch of TLV parsing happens. This is the really verbose output, by the way. So it pulls out the values that it's looking for, and then it basically says, right, we've got our stuff. We go and execute the command, and then we build a new packet, encrypt it, dump it on the wire, and send out the response. So that's basically what's going on behind the scenes. Any questions? There's a fair bit going on there, but that's kind of like a 30,000 foot view of the general process of how a command is handled. No questions? Fire those questions at me as they come in. Okay. Now, what I'll do here, let's just exit out of that session. And this time, let's clear that out. I'll run the HTTP version. And you should notice that HTTP behaves a little bit differently. And it's constantly updating. You see that? 1000, 1200, 1300, 1400, 1500. So this is because HTTP polls, right? So it sits there and it waits. It basically, once it's done a bunch of command handling, it does this thing called an incremental backoff. And that basically means that it'll connect repeatedly really quickly. And if it's not getting anything, it'll start slowing down, slowing down, slowing down, slowing down, and slowing down. And eventually it will get to a point where it's like it waits 10 seconds or so before it calls back. So what we can do is if I go back over here, type get UID, oops, you can see it's done it all again. So it's so quick. And like I said, there's a lot of noise. In debug mode, there's a lot of noise for HTTP. Let's turn off auto scroll for a second. Actually, we'll stop capturing. Scroll back up here a bit. Okay, there we can see this is where the pack came in, get UID. And you can see that dispatching is a bit different because it's using HTTP. All right, so this is the level of debugging that you can get out of Meterpreter if you really, really want it. Reckon this incremental backoff would be worth having blue team look for on the wire? Definitely. Yeah, at the moment there's no jitter at all, Justin, in this. It's pretty predictable traffic pattern when a command comes in. So yeah, I think so. From a red point of view, there should be some kind of jitter involved. And that, again, at least for me, has been on the to-do list for a significant period of time. It's just not something that I've got to. But at the end of the day, I mean, when you get to a point where this is working, you've probably got bigger problems than jitter. Meterp sessions would be lost in the noise. Yeah, look, I mean, you could take the approach that Cobalt Strike has and make that completely configurable and configurable on the fly. That would certainly be useful. But at least having jitter around the back off so that it might start quick, but each one of those requests is at sort of random intervals. That would make a lot more sense. Okay. All right, so let's just quickly validate the premise. All right, so I'm just gonna not capture anything. And we're gonna exit out of that. First of all, I gotta make sure that everything is working. So let's fire up TCP. Okay, now this is how you add a new pivot. Okay, so the way pivoting works is it doesn't just funnel connections all the way back down to Metasploit. When you set up a pivot listener actually operates as a listener. So what you have to do is you have to say, I want to listen on this named pipe name, and I want you to stage 32-bit payloads or 64-bit payloads or whatever it happens to be. But the way that it works is it's actually pushing up one copy of MetServe DLL up to the session, and it sits there and waits. So when you create a listener, a pivot listener, you need to go pivot add, and you give it a type. At the moment, pipe is the only type that's supported. The aim down the track would maybe to be able to listen on a port and sort of pivot through yourself in that manner, whether it's HTTP or TCP or whatever. There might be other ways like WMI listeners, but the goal here is down the track to have more types that you can listen on. So we're going to listen on whatever the pipe host was, which is the same IP as the one that's come in. So that's what -L means. The name was like, I think it was what the fuck, LOL? I think that's what it was. Should probably check that, hey. Oops. Yep, what the fuck, lol. Okay, so that's the pipe name. And then you need to give it an architecture, which should be 64-bit, and the platform is going to be Windows. All right, so successfully created the pipe pivot. Now I'm not listening to anything here, right? But what I'm going to start capturing packets now. I'm going to kick this off now. I don't know whether this has worked or not. Hey, Firefart's in, and Peleus. Thanks, guys. Good to see you both. I mean that with the utmost respect. All right, so when I run this MET-x64 pipe, what should happen is this payload should attempt to connect to the current listener, and that listener is the name pipe listener, and it should establish a new session. We should see a bunch of noise in here, assuming everything works. Doesn't look good, does it? Let's see if that's even running. MET64 TCP, that's still running. Oh, there we go. I didn't actually run it. What a fool. Okay, so they're both running now. And look, see how that died really quickly? I wonder why. Maybe we've got... there's no notification here whatsoever that, that we've got to connect back. So let's just see what happened here. So, reading in a header... Core channel EOF. So I haven't looked at this stuff for quite a while, so I'm going to be fumbling a little bit here. But let's see. There's nothing. See, this is all TCP related stuff. So I would have assumed that we shouldn't get any TCP related traffic info here unless. See, look at that. Nothing's happening again. So let's just make sure that we've got all of our parameters correct, because clearly that's not behaving as I would expect. What I'll do actually, let me take a copy of these, put them locally, because I might start running these as admin. We can close that window off. Let's just run that as admin for a sec. That might actually be part of the reason. And we'll make sure that the listener pivot add pipe 192.168.20.128. That's definitely the IP. Ah, I missed. It's WTF. Okay, I'm going to blame every single one of you guys for not picking up on that. That was a bit of a fail, wasn't it? So the name pipe name was different. That's why it wasn't picking up on anything. Far out. Calls for more dark chocolate, I think. Spraying it all over my desk. Okay. So, I know. Tripos are the best, aren't they, hey? Alright. Did I kick off the listener? Yeah, I did. Alright, here we go. This is important, so pay attention. You can see that I'm sending a packet in, it gets decrypted. Yep. Then we see that the command that's come in, core pivot add. So that's saying we want to add a pivot. Then parses the entire packet and dispatches that packet to the handler. The handler says, right, go and find me all the metadata that I need. And here we can see the named pipe server kicks off and says, right, I'm creating a new server instance at this location. So here's just some standard debugging related stuff. So when it comes to named pipes, there's a bunch of permission related nonsense that's really, really tough to work with. And so the aim is to make the name pipe as open as possible for anyone to be able to connect inside the current context. Now, the one thing that it doesn't currently support is null sessions, but at the moment that's really not that much of a concern, because a lot of the time when you're dealing with this, you're in an Active Directory environment, and usually you have authenticated sessions that you're pivoting through. So far it's not been too much of a concern. Anyway, so we're creating the handler here, the listener, and we're scheduling something to sit there and wait for things to come in. Now, one thing to note, this is important, and this could actually be part of the problem down the track. So we have this thing called a pivot tree, which is basically just a binary tree that maps session identifiers to transports. So when we get a pivot session actually come in, you get a pivot session come in, we need to tie a session identifier to that session so that when packets come back out of Metasploit, we can look at that ID and go, oh, that's for that session over there. And we keep track of that using this binary, this binary tree. Okay. So we do all the things. This you can see is this A608 thing. That's the session identifier, and that's at the head of the list. Okay, the head of the binary tree list. And then from there we respond with, yay, we've created it. Everything's hunky-dory. All right, now let's see if the actual pipe invocation works. Fingers crossed. There we go. Look at that. There's lots and lots of stuff happening. So you can see there's two. This is one of the painful things about doing it all on the same VM. You can see 9088 is one of these processes, which is, there you go, that's the named pipe one. And then there's this other one, 5, where is it? So that's just the staging process that we can see. More packet parsing, and there you go, 5004. That's the man in the middle. Okay, so there's going to be a lot of noise, but we can filter out based on the process, which is probably what we'll start doing soon. But anyway, what should happen is you can see here we now have an encrypted session that pivots via the other session. Okay. So that's the way of knowing that you've actually got a pivot in place. So it should say pivot via whatever this transport here happens to be. All right. So we can talk to that, and it should work exactly the same. Yeah. All right. Good. Okay. So we're at a point now where we know things are behaving as expected. Let's now kill off all of the sessions that we've got, and this time we're going to kick off another HTTP. We'll let that do its thing. Let's set up the pivot listener again. Pivot add. Right. Now this is where the magic's going to happen, right? So we should be able to kick off this pipe, and I would assume that at least one of these processes is going to terminate, if not both of them. Okay, here we go. Boom. It's dead. Oh no, there you go, now it's dead. So the pipe is still running, but the man in the middle is dead. So the bad thing about HTTP is that you don't know for sure that a session is dead because it stops talking to you, and you just might be waiting for a timeout, right? So here you can see every time we check the check-in, the time gets longer and longer. This is a sign that bad things are happening. And as we know, the process at this end is not actually functional. It's gone. It's completely died. Now here you can see the name pipe thing is still doing its connect back. So no encryption didn't get established. That's correct. It's because it didn't get established. It's got nothing to do with the transport. So remember, the initial process when you have a connection connect back is once it's got metserve running, metserve then negotiates encryption keys and then encrypts stuff. So it hadn't got to the point where it was able to negotiate any encryption key, and therefore it thinks that it's currently not encrypted. Okay, so this is interesting, right? Because leading up to this, we had two processes. 7292 was the one we cared about. All right, so now what I'm going to do is let's highlight in, I don't know, oops, some other semi-reasonable color, something that's not too garish. That's garish, fucking whatever. Let's include 7292. That didn't help. Why didn't that help? Oh, it's because it's on the PID. So, can I? No, I can't. Oh, let's worry about that in a minute. Let's just keep an eye on these 7292 here, right? So what I'm going to look for is the last error message that we got. Ahmed from Brisbane. Greetings, sir. How you going? Thanks for joining in, mate. Atwolf. Purple. Good choice. Right now I seem to be failing at that completely though. So anyway, so what happened here? What do we got? We've got... Here we go. So let's just scroll back up here a little bit. Now it's important to understand the process of actually staging a new packet, a new pivot point, because it's actually a little bit painful. When the session first comes in, there is no GUID. So you can see here, hang on, we've got a null GUID. So we are going to give you a GUID. So the man in the middle says, you don't have a session ID yet. I'm going to give you a session ID, right? So it generates a GUID, and that's all this is. It's a GUID with all the curly brackets and hyphens and whatnot done. And so we add that new session to the head of the tree, right? So then we inform MSF of the new named pipe pivot. Now, that's when we saw this appear. So Metasploit goes, oh, we've got a new session. Great, we should make good use of that. From that point, what are we doing? We're sending that to Metasploit. So that's just doing the usual packet TLD stuff. And then what are we doing? Testing data on the pipe, make sure there's enough of a packet header. So it just sits there and it waits. Okay, now here we go. So it receives a packet that's come back from Metasploit, right? Now what is it doing? It is decoding the packet header, and then it looks in the packet header, it goes, what's the session ID that maps to that particular packet? So we're saying here that it's A2DBF, which matches the root. So this is a packet, not for our current session, but for the session that was just created, right? So we get that and we go, hang on, the session GUID doesn't match. That means it's not ours. So we go to our pivot tree and go, hey, we need to find one by this GUID. And there we go, we find it at the root of the tree. So we go pivot found, dispatching packet on a thread to avoid main thread blocking. So we want to chuck that on a packet dispatching thread so that our main receiving thread doesn't block. Okay, so from there, what happens? We've got, you can see the thread IDs change here to 1264, dispatching packet on thread. Packet receive on the previous thread has finished, and it's basically returning a result of nothing. So testing for data on the pipe, making sure there's enough for a packet header. So this is now back in the named pipe payload. So it has received the packet, right? As we can see, all of this stuff here has received, hang on, where are we? Ooh, that's interesting because that's the last thing that we see. See that? As part of this process dies at this point here, this return result 0, writing a total number out to the wire, and then it carks it. But anyway, it looks like the packet does actually make it out, right? So you can see here, where are we? Local packet payload successfully allocated copying data. So this is decrypting, it's decrypting the header. And as you can see here, right, attempting to locate base command core negotiate TLD encryption. So what this means is the packets come from Metasploit. Metasploit said, we want to negotiate encryption. So send that packet down the wire. The man in the middle has gone, yep, okay, that packet's not for me, that's for these guys. So it's going to pick the node out of the pivot tree and send the packet down the wire that's associated with that node in the pivot tree. Okay, and this, what we're seeing here on screen now, is the named pipe transport receiving that packet, pulling it apart, and and basically invoking the TLV encryption handler. So there you go, that's what this is. And then it goes through, look at that, it's doing its normal thing up to, hang on, where are we? Negotiate TLV encryption, resetting, hang on. So what happens here, right? So it's in the process of figuring out what it should be doing with the encryption, but then back on the main thread that's listening, it says, where are we? Moving transport. So on this 3C8, which is the main thread, you can see here, that's the main thread there, and it's dispatched the packet handler on a thread. And then the next thing that happens is server pipe hole return 109 exiting dispatcher. That means that its connection to the name pipe listener, which is the man in the middle, has just disconnected. So this is when it realizes, oh, the thing that I'm pivoting through doesn't exist anymore. Okay, so that's obviously bad. And then from here, basically everything that we're seeing is, that's it actually doing its encryption negotiation stuff. And then back down here, we're just trying to connect back. And as we can see, it's still running. Right? It's still running. So it's going to sit there and keep polling, keep polling, keep polling. So if, for example, we kicked off another HTTP, and we jump in that last one, if I create the pipe listener here, once it's created, it should attempt to connect back pretty much straight away. There you go, it's doing it again. Boom, it's bailed out again. Oh no, actually no, it's not. It's not even behaving properly. So what's happened here is it's trying now to kind of recover. So it looks like we've got multiple issues. What should happen is that the pipe should reconnect to the new listener and get staged, but this is effectively a stageless payload now. So it looks like stageless payloads connecting back to a staged handler cause problems. But what's interesting is that it hasn't crashed, right? So I'm going to end that task. Let's fix one issue at a time. Let's launch a new pipe. See how long this process lasts. And there it is, it's gone. Pretty interesting, hey? So it looks like we've bailed on exactly the same spot. Okay, so now we're going to start backtracking through code, try and figure out what the hell's going on. And then when that's done, maybe we'll look into fixing stageless connectivity at the same time. Alrighty. Are we making sense? Everyone's still with me? Any questions? I realize there's a little bit of assumed knowledge here. We've already spent 50 minutes babbling and talking about context before we can even get to a point where we know what's going on, but that's the nature of the game. Righto. Now the error message, sorry, not the error message, the last debug message that's come up is in here. Dispatching packet on thread. All right, so pivot packet thread. Pivot packet thread. Dispatching on thread. I remember when you were doing this last time, create name pipe handling, and when you were writing the pivot tree code. I think it was a good base for what you're talking about here. Awesome. So far, so good. Marcus Hutchins. Is that like legit the Marcus Hutchins? As in malware. God, I've gone starstruck all of a sudden if that's legit Marcus Hutchins. Help me out here. Help me out here. The guy that registered that epic domain. Malware Tech. Yes, Malware Tech. Thank you. Now, is that legit him? Really? Holy shit. That's not intimidating at all. Wow. Okay. Thanks. If that is legit you, man, I'm stoked to see you chime in. I'm a little flabbergasted. But yeah, cool. That's cool. Okay, so these are the two functions that are basically designed to make sure that the pivoting code dispatches packets on separate threads so that we don't tie up the original one. We need a proof of malware text Twitter. Yeah, I hear. Citation needed, hey? All right, so what's going on here? We are writing packets on the pivot context and freeing the packet buffer. So packet dispatch. Now let's just quickly duck back to here. Dispatching packet on thread. Then we get to writing a total of, hang on. Aha, okay, so we call packet write. Packet write has its own debug stuff in it. Packet write is named pipe write raw. So this is where we should see writing total of whatever bytes. So we wrote 571 bytes. Oh, we should. Hang on a second. Wrote. Okay, so writes 571. That's where that first thing comes in. Writing a total of 571. We wrote all 571. And then 1DC. That's the last thing that happens. Really? So this happens, and then it's going to bail out because we've written all of the bytes. Then we go lock release. So we basically, at this point, we're locking the write lock because we want to make sure that we're only writing sort of one packet to the buffer, to the named pipe at any given time. And that's it. So we don't even get here. So what that implies really is that it's not this thread that's killing it. Otherwise, because what we can see, right, we've got, we're only debugging, writing debug output. We're not doing anything magic. Same story here. We're not even hitting this lock release because we don't see this message appear, right? Server write finished. What we're seeing on this thread, this 1DC8 thread, is that. Although it is fair to say, oh no, we didn't even get to this. So yeah, I'm arguing that given that we saw this and we didn't get this or this, then it's not this thread that's causing problems because this instruction here isn't going to cause a crash, right? So my guess is that it's the original thread that's causing problems. So that's basically this 140C, return result 0. So let's go back to packet dispatch and let's see what's going on here. So what we do when we've written the packet, we free. So this packet buffer is just a big block of bytes. We know that the packet buffer is going to contain the entire packet that came from Metasploit, which includes all the metadata. It could be encrypted for all we know. We don't care. All we know is that it's a fixed size and then we need to take all of it and shove it down the neck of the target. And then we say packet dispatched. So again, we don't come out of this call because we're on a thread, right? None of this stuff gets executed or outputted. But what we should be doing is freeing that memory up, killing off our own sort of thread context, and then bailing out. Okay. Now, we're back on our master thread, this dispatch. We want to see what's going on after this dispatch happens because clearly this is what's causing the problem. So we've got HTTP packet receive finished. So leading up to dispatching on packet on new thread. So here's where we actually create the thread to dispatch. That was a fake account as far as I know. Yeah, I was going to say, I would be very surprised if somewhere like Malware Tech would be sitting in on something like this. But I had a moment there where I thought, is that a possibility? No, that's not a possibility. Okay, so here you can see like we create the thread context and then we say go off and be merry. And thread invoked is something that we should see somewhere around here. Packet with thread invoked, there you go. So that's one for, and then cleaning up. So let's just see where this gets invoked. Pivot packet dispatch gets called in here. Pivot found dispatching packet on thread to avoid main thread blocking. So we saw that here, right? And then we're calling set last error packet pivot dispatch. So that'll return success or not. Then what happens? So we've got this reference to a packet buffer, which we then pass off. So we don't really care about it at this point, right? We set both of these things to null because after the fact, we rely on these things to be non-zero or non-null to clean up. Now, as you can see, we get down to here, and then we call cleaning up. Cleaning up gets called. Packet receive finished, which also gets called. And then we've got returned result 0. So we need to know what invokes this function, which I think is a fairly generic handler. Packet receive HTTP. Okay, oh, this is good. I was concerned about this. I was thinking that maybe this would be part of some generic wiring that invokes function pointers depending on the transport, but thankfully we are still in the WinHTTP code, so hopefully we're going to find it in here. Okay, so this packet receive HTTP should come back with a result. Okay, so that returns error success, right? We can tell that because it returned result 0. Right? Dispatch return result 0. So that happened in here. Is that where that was? Packet receive HTTP. Okay, so did we get a message down here somewhere? Dispatch. Here, okay. Aha! Notice that we didn't get this. Right, now this is pretty key. And I'm wondering why this code ever worked. So clearly, the condition that we've got here is we are not responsible for handling the packet. Okay? So we want to make sure that the packet's ours if we're going to handle it. But as you can see, we invoke packet receive. So we do actually get a packet. And when we call packet receive, we return success or failure. So in this case, result, when it says result doesn't equal success, we basically just say, hey, bad things are happening, bomb out. But in the case where it is successful, which is here, we've got some metadata that we need to keep track of, such as when the last packet came in, because we use that for session timeouts and various other things. But what we're not doing is making sure that the packet that we sent out was handled. Okay, so when we pass in packet receive HTTP, in this case, oh, I know what it is. I know what it is. Where is it? See how we set the packet to null? Yet, over here, as soon as we come out here, the first thing we do is we try and handle. We try and handle the packet at this point. Oops. So, what should happen here is all of this stuff should effectively bomb out. So we don't want to do any of this. Now, is anything else happening? So we should do this. We need to bomb out at this point. Now I'm going to put something in here that will at least give us an idea. So we should be able to go, right, if the packet doesn't equal null, we want to do all of the stuff that we were doing, right? Otherwise, let's go dprintf. Yeah, we'll use that. Excuse me, dispatch. Packet was null. This indicates that it was a pivot packet. Just so that we know, right? And that's all we need to do. Everything else can and should be left alone, right? So what was killing us is that inside this command handler, the first thing that we would be doing is pulling something out of the packet, right? If we go back to the original bug, we're dereferencing a null pointer, right? So RCX would be the pointer to the packet plus 28 bytes. So that would be inside the TLV parsing, that's what would happen. The issue does happen with HTTP and HTTPS. Yes, Atwolf, that's exactly the problem. How did you jump to the corresponding bracket just then? Atari. Very good question. This is more Vim shenanigans. So in order to do that, you can use the percent sign. All right, so if you watch, I'm there. If I hit %, it jumps back and forth between the two. It does that with curly braces, does that with parentheses. It might even do it with quotes. There you go. Oh, sorry, the other brackets. So square brackets, angle brackets. I wonder if, I don't know whether it does it with these or not. Let's find out. Yep, it does. So basically anything that would match in brackets, you can jump to by repeatedly pressing %. I actually prefer to use tab for that. So I've got a key mapping in my Vim config that allows me to just hit tab and it jumps between the two, which is kind of cool. Anyway, so with that in mind, I'm going to rebuild that. I shouldn't have modified base.c. That's going to cause a rebuild of all kinds of shit. Anyway, so what I expect to see as part of this now is this message appear. Packet was null indicates that it was a pivot packet. And then we can just forget about it, right? All right, so that's built. I always rebuild again because I just want to make sure that everything is good. For some reason, WinPMem always gets rebuilt because I think it's got some compiler specific directives in it that change the source when it's built, but yeah, should get rid of that because that's irritating. Back over here. So I'm gonna restart that because it's faster. I'm gonna copy the DLLs over that we've just built. Okay. Thanks. Swear jar. Yeah, I know. I should have a swear jar. I'm getting angry. I just came in from putting the little one back to bed. If this relates to the bug we were hunting, why would this null aspect only apply to HTTP and not TCP? Very simple answer to that question. Because, as you can see, this issue is in the dispatching of HTTP transport related stuff only. So TCP has a whole different dispatching process because it's got an active TCP connection, right? So let me show you. If we go to the metserv transports, there's dispatch for each of the different types. So we've got a named pipe transport, TCP, WinHTTP, and WinINet. Now in TCP, there is a, where is it? Dispatch, server socket, server dispatch TCP. So here's where the TCP specific stuff happens, right? And clearly we already handle this appropriately. So What are we doing here? Getting server socket poll, getting a packet. Here we're going. If the package is null, no packet received, probably just met server being ignored. Either that, or because the packet's null, we end up with this bypassing the issue. So this could have been a fluke, right? So what I might do is go ignored or a pivot packet being handled. Okay. Now, that actually happens in the case where a fully staged or stageless payload connects back to an existing listener and receives a stage. So we may actually have fixed 2 bugs in one in this one case. Is there a function for dispatch HTTPS that you need to make the same change to? No, at Wolf, we don't need to do that because HTTP and HTTPS dispatching functions exactly the same. The only difference between the two is that certain flags are set up on the HTTP transports as a result of there being HTTP or HTTPS. So let me show you where that happens. There are a set of INET flags, so server init. So you can see here, when you've got proxy related stuff, etc., when HTTP connect requires this context internet handle. Now the internet handle is set up as part of this when HTTP open, okay? Then every time we do a request, we have to create effectively a new request object as part of the dispatching, right? So let's go back to here. While running, we do packet receive. So going back into packet receive, you can see we've got this create request function, right? The create request function varies depending on whether there's win INET or win HTTP behind the scenes. So in create request, which, you'll see for the 2 different types of transport behind the scenes, we've got get request win HTTP and get request win INET. So if we go to the definition of the win HTTP one, you can see here, right, we're checking, have we marked it as secure? Sorry, if you want SSL, i.e. we're using HTTPS, we're just setting a different flag. Yep, okay. So as far as the actual mechanism for moving data across the wire, regardless of whether it's win INET or win HTTP, all of the SSL and non-SSL stuff is basically configured on the fly for every request. The reason why we don't have to care about doing this stuff anywhere else is because the dispatch code, this dispatch code here, is the same whether it's win HTTP, win INET, HTTP, or HTTPS, because all of that other stuff is abstracted as part of this generic functionality, right? So whether it comes in on SSL or not, whether it comes in on win INET or not, we will always land here. And this is where we needed to check for null. Does that make sense? I hope that makes sense. Peleus, what about win INET? Okay, so hopefully I've answered your question there already. What about we fix get fuck, someone had to say it, didn't they? Someone banned Justin. Trust you, Justin, bring that up. Yeah, at Wolf. God damn that guy. All right. For some reason I rebuilt that. I think it's okay. So we're ready to go. Okay, let's see what happens. I think we've got a good chance of nailing this. So we'll fire up HTTP. Is it going to remember my pivot stuff? Yeah. You know that feeling where you'd rather not type it all out again? Let's just scroll up and copy and paste. That's the one without the T and the F. There we go, pivot add. So, add the pivot. Cross your fingers. HTTP. It's not crashing. Boom! Come on, please work. Yeah, check it out. All aboard the fail train. That's awesome. There you go. It was literally a check for a null pointer. That's all that caused that to fail. Now, here's the thing, right? When you exit out of a pivot session, so if we go in here and we exit, see how it closes the pivot listener. It also closes the sessions that it's pivoting through. So what it does is it kills off the current metserv, closes the sessions, but it doesn't kill off the pivoted session because, like, technically you didn't ask for it to be killed off. So let's see what happens now if we go through the process of re-establishing the listener. Because this is the other bug that we want to fix, right? Ready, PS sysinfo, pivot add. So as soon as I hit this pivot add, this is where things could either work really, really well, or they could crap themselves. I'm guessing based on what we're seeing there so far. Okay, so the pipe, oh, the pipe's just connected. Oh, the pivot's just come back. Woohoo! Okay, so that check for null also catered for the case where the staging process has pulled out something that's not a packet and it's ignored it. Yeah. 2 birds, 1 stone. Happy with that. That's pretty cool. Hey, that wasn't anywhere near as bad as I was expecting, but it does beg the question, how the hell did that work to begin with? Welcome to development. No more chocolate for me. I don't deserve it after that. So, yeah, there we go. That was actually not so bad, yeah? What do you guys think? Does that all make sense? Do you have any questions around the mechanics of how this stuff works? I'm pretty excited about that. Someone gift that dance. Justin, you need to share that video link again. Several months and a 1.5 hour stream for a 1-line code fix. Shut up. Sad but true. Sad but true. I am sorry to say. Hey, look, you know, I'm a busy man. Didn't see any of you jerks submit that 1-liner. But yeah, anyway, you're right. I should have got onto this a fair bit earlier, but you know, there we go. Oh, this is another interesting little feature. I don't know whether you noticed, but see how I went sessions-k. So it actually knows that this session was pivoted through here first. And so this time, all of the sessions are actually gone. Because when you -k, you got to go, if I kill off this session, are there any other sessions attached? And if there are sessions that are pivoting through, it'll go, oh, okay, well, I'm going to go and kill off that session that's attached to it first. Yeah, how good is that video? Hey, so good. If you're on stream, if you're watching this stream even after the fact, make sure you go and watch that video, because that was, I think, off the back of, may well have been the very first live stream that I did, and it was the Capcom thing. Is that right, Justin? It was the Capcom thing. I'm not going to click on it right now, but I'm pretty sure it was the Capcom driver thing, and I had like a pink shirt on, and yeah. That's hilarious. Very well played, Justin, you jerk. Yeah, that was cool. All right, so what we should probably do is should PR this. Although I'll PR that off stream. That's not a particularly exciting thing to do. But I'll share a link to the pull request in the metadata associated with the video that's archived on YouTube and all that sort of thing. But yeah, I'm pretty happy with that result. Hey, like everything else worked nicely after that. So is there any difference between setting up a transport add pivot versus setting up a listener with a multi-handler that happens to map to a meterp session? Yes, there is. Because the listener that maps to a meterp session is, while it might be listening in Meterpreter, the staging process still goes all the way back to MSF. So if you can imagine, you've got your Meterpreter session, you've got your Metasploit listener. in the scenario you're talking about, Peleus, when a connection comes into Meterpreter here, the staging process goes all the way back to Metasploit and back, and basically it's funneling all the data back and forth. Whereas in the case of the reverse named pipe pivot, you're taking a pre-configured stage and pushing that up to Meterpreter. So it's actually got a copy of Metserve in memory, right? So that basically means, like if we kick off a TCP session, oh, I didn't run that properly. Kick off a TCP session. Let's turn this off. Right, so sessions, let's add the pivot here. Okay, so we've got a pivot listener. I should be able to, right, when I run this named pipe handler here, what's happened is we've ended up with a session come through the pivot point, but Metserve, the original DLL Metserve, is pushed directly from one Meterpreter instance to the next. It doesn't go all the way back until that's actually kicked off. It also means that I should be able to run it again. We end up with another one still going through. Ooh. Sorry. There you go. So these are both pivoting through this one, right? But every single time that that happens, the staging process happens within the network. So the aim for this packet pivot thing and the staging process was to make it so that instead of pushing thousands of copies of Metserve up from Metasploit, we've only got the one and it's hosted inside that one pivot listener. Does that mean the name pipe version would be payload type dependent while listening on a Meterp session is payload type agnostic? No. The listening on a Meterp session is not payload type agnostic, and neither would the MSF listener be. I mean, with HTTP, if you use a multi, then you would, but with TCP, you don't get that anyway. So as you can see, like when we create the pivot, we're saying, this is the name pipe, name, and it's a Windows payload we're hosting, and it's 64-bit. Now, the reason why you do this as well is because like down the track, you should be able to pivot Python payloads through named pipes if you want to as well. So we should be able to stage PHP or Python or whatever can talk in on named pipes. It should be able to do exactly the same thing. Okay. So you basically say, I want to generate a Windows 64-bit Metserve, and that's pushed up and bound to this handler. And so anything that talks to that gets served up a copy of that stage. So it basically becomes a staging thing in the middle. Does that answer your question? I think it should. I hope it does. Kinda. What's missing? So I want to make sure that that's clear, because I'm sure other people are asking this question themselves. That stage would be a specific Metserve payload. Exactly. You are telling it when you create this pivot, you're saying to the current session, I want you to open up a named pipe with this name. And what I want you to do is take what I'm about to give you, which is a Metserve payload, and I want you to host it. Right? You're mixing transports and Metserve. Okay, so let's just quickly cover it one more time to make it clear. So we've already said, like in this case, we're dealing with named pipes only. So we are saying, listen on this named pipe handle. And with that listener, we want to associate a Windows Metserve payload that is 64-bit, which means that whenever something comes in and connects, the first thing you do is serve that up so that the thing that's connected receives the stage, stages itself, and then connects back to you and starts the handshake. And then from there, that's when the packet pivot thing kicks in. So once Metserve is actually taking over the name pipe transport, at this point, it's sending packets and that bounces all the way back to MSF. And then it pivots through. And the good thing about this is that once that stuff has been set up, MSF then negotiates, as you can see here, it negotiates encryption. And so that means that the man in the middle, this thing here, doesn't know the encryption key for this guy here, but it's still able to pivot the packets because it's just looking at the packet metadata. It doesn't know the contents. It just knows that that session needs to bubble traffic back and forth through it, okay? So that's always named pipe, whereas the stuff you're talking about is kind of transport agnostic. And when you do that, what actually happens is that the listener, which is sitting at the other end in Metserve, in Meterpreter, is actually funneling things through channels, which has the overhead and all of that sort of stuff. So there you go. We have Zfixes. Does that help now, Pelias? Does that make more sense? So the packet pivot through named pipes literally takes packets off one wire and puts it on another. Whereas when you do what you're talking about with setting up a listener in a generic sense, everything goes through channels and you get the added overhead and therefore the pain. Hopefully that will make sense. Now, actually, before we go, you know what we need to do? We need to do what I said we were going to do and make sure that Win32 works. So while that's building, stream msf.rc. So let's do 32-bit versions of these puppies. Okay, so they're all good. 286. Now I don't actually need the 86. And we'll just increment these by 1. So that's all good. So they're all 32-bit versions. Now we need to do the same here. Increment. Oh no, I did that wrong, didn't I? Okay. So that should allow us to generate 32-bit payloads. We're going to make sure that they work. And so once we validated this, I'm going to show you that you can have multiple listeners on the same endpoint with 2 different architectures and types. I'm going to have to change this. I can no longer set G because we need different pipe names for the different payloads. So that means I will have to go set pipe name what the fuck lol64, and this one here will be, we'll do 86 just to keep it consistent. Okay. So Pelias, does that make sense? Any other bugs to fix? Hey man, I'm sure there's shitloads of bugs that I need to fix in here, but this is one that that has been on my to-do list for quite some time. All right, so let's kick off another MSF console. Yeah, I think so. Don't worry explaining if I'm wrong, but I should have said, does that mean that the added pivot is transport type dependent, whereas the multi-handler stuff is transport agnostic? So again, Pelias, if you have a look here, and this, I think this was mentioned possibly prior to you coming on stream, which might be part of the reason, but look at this. Remember, when you adding a pivot, you're specifying the type, i.e. the transport type. So at the moment, the only pivot transport type that works in this scenario for packet pivoting is pipes, i.e. named pipe. So we're setting up a named pipe listener with that pipe name on this host. Okay? And the reason why you have to specify the host here is because the stage that's generated needs to include the configuration that pushes the IP for the connect back for future reconnects. So yes, that there is specifying the transport type. So down the track, I hope to add HTTP, HTTPS, and WMI, whatever. But at the moment, pipe is the only one that's actively supported. Okay, so what happened here? Okay, so there we go. We got our jobs, 64 and 32-bit. Looks like 32-bit payloads have been built. So that's the copy for the 64-bit. We also need to do the Carrier pigeon is probably worth it for Australian internet connections at Wolf. That's what I was getting at in a very badly explained way. Okay, cool. Thanks for taking the time. Yeah, no worries, man. It's really important that we're all on the same page there. So those kind of questions are important. Okay, let's run some 32-bit payloads now. So here are the 32-bit ones. Let's start with this. Oh, actually, you know what I need to do? Because I've regenerated all of the payloads. I should copy the 64-bit ones over as well because they have a different pipe name in them. Okay, so we've got a 32-bit session. Let's add a named pipe to it. Sessions -1. Pivot, add type, pipe. L is the same IP. The name of the pipe is WTF lol 86. And the architecture is x86. And the platform is Windows. Okay, so you can actually go pivot list, I think. Pivot list. So you can see that we've got an identifier for the pivot. That's the information and that's the stage that's hosted. That would probably help understand this, hey, Peleus. So on this named pipe, based on the fact that we've specified pipe there, we are staging a 32-bit Windows, okay? Let's see if it works. You watch, it'll probably shit itself. Ooh. Boom. Handy Andy. All right, so that's working, which is great. Oh, ye of little faith. Yeah, I know. Well, let's do this. Let's set up another one. Pivot add pipe. What the fuck? 64 with a 64-bit payload. Pivot list. Okay, so now this thing is pivoting both 32 and 64-bit, which means I should be able to do that and that. Okay, what happened there? Ooh, this one is actually... What did I run? Did I run the wrong thing? Oh, I ran another 32-bit. What I meant to do was 64 pipe. There we go. So you can see we've got that one there as the pivot point. We've got a 64-bit... Oh, hang on, I've got two 64-bit ones running. I haven't got a 32-bit one. 32-bit pipe. There we go. Okay, cool. So we've got a 32-bit coming in via a pivot, which is listening here, and two 64 bits coming via pivot. So we've got the one session and it's pivoting 3 sessions through it. And as you can see, pivot list, it's actually, this is what it's talking on, right? So if we get rid of 5, 6, and 3, fuck. There we go. Right, so what you can do is you should be able to go pivot, remove, right? So remove I. Now what I should do is have like a 1 and a 2 next to these, but if we want to get rid of the 64-bit one, you remove 2. Oh no, I is the identifier, so you give it the ID. My bad. Pivot list. There we go. So that's how you get rid of pivots. So you can keep the listener up there as long as you like, and then you can remove them after the fact. Now what's actually really important is this. So we've got the 32-bit one listening. Let's kick off a 32-bit. So we end up with the sessions, right? I'm going to go pivot remove that. Oops. Got to do the -I. Okay, so that doesn't kill off any existing sessions. Okay? So we have a pivot listener and we have a pivot actually coming through. We might have 5 sessions pivoting through the current name pipe. When you remove the pivot listener, you're literally removing the listener for new connections, but all the existing connections remain, right? So this should still work. Does that make sense? Connection info would be nice if it had the pivot name. Yeah, I do agree, but at the time it's more meaningful, I think, to have something here that maps it back to this. At the moment, there's no nice way of drawing something that says, hey, this lives in here. So what I'm thinking of doing as part of the next thing is instead of having it so that it comes down pivot via like this, as we're looping through the sessions, when we get to one of these, we check to see if it's got any pivots and we display them with like a little tree view directly underneath so you can see which ones they're associated with. So yeah, that's basically what I'm looking to do, is have some kind of tree view that demonstrates that. It has all the information like this as it does before, but there's like a little tree view. Yeah, a little tree view would be nice, hey? So then you can see the nested ones. So there's another thing I'll show you. All right, so let's start with a 32-bit listener. I need to test 32-bit HTTP in just a second as well. And so what I'm going to do is we'll go sessions -1. Let's add pivot, because I can't be bothered typing. So we've added the 64-bit pivot, okay? Now I'm going to pivot through this. Okay, just wait for it to stage. So obviously there's a little bit of overhead. So what I'm going to do now is, oops, sessions -1, is I'm going to add the 32-bit pivot to the second one. I should have just typed it out again. Hey, there's the 64-bit one. 32-bit. Okay, pivot list. Okay, so this session is the one that's already pivoted. I haven't done this for a while. This could be a make or break. But what I'm going to do now is kick off the 32-bit session. What happens? Did it run? Ooh, we've possibly got an issue. So what should happen is, oh no, this is not a supported feature. This is not a supported feature. Chaining pivots together, I haven't actually built support for. And the reason for that is because it's surprisingly complex, at least given the way that it works. So that is a known non-working condition. So I'm going to terminate that and pretend that we never did it. I'm going to test HTTP, but let me quickly explain why that's the case. So every single session, bearing in mind, right, we are not doing what Cobalt Strike is doing here. Cobalt Strike works in a bind fashion. So Cobalt Strike will connect outbound to a single point listener. We're dealing with the reverse. So the new sessions are coming back out and connecting back. And that's because we want the ability to have resilient transports, right? So basically the way that this works then is the pivot in the middle has a binary tree, and that binary tree basically says, I need to send this packet out on this particular transport. So for us to support nesting, what has to happen is the tree, you'd have MSF 1 and 2. Okay, so you've got this one pivoting through this one. Then you're going to add another one. That needs to pivot through here, and this still needs to pivot through here, which means the packets that are coming back out this way hit this point first. So this point needs to know that the packets for this session over here have to go via here. So you end up having to have more than just like a typical binary tree style mechanism. You need to have multiple session IDs pointing to a single transport. So there's more accounting that needs to be done around that, and I just haven't got around to it. So pivoting through pivots at this particular point in time is not a supported feature. But that, maybe we can actually develop that together on a future stream if you guys are interested in seeing that. Anyway, before we go, let's make sure that HTTP, did we already check HTTP? We didn't. Let's add a pivot of 32-bit. I always do -X because I like to see the check-in times. But as we can see, it is functional. Excellent. Boom, we're done. We are Dunskies. Any questions, people? Any questions? No? So that was, that's about an hour and a half, probably half of the time I spent babbling and backfilling with information. I'm hoping that there was something more useful. It wasn't just a, oh look, we've fixed a, oh check this out. Clearly that didn't kill the session off like it should have been killed off. There we go. Yeah, I'm kind of hoping that as like by doing these streams on the dev side and fixing these kind of bugs, it's not just a case of, oh look, you know, I can see why that thing crashed. It's an opportunity for us to go through the mechanics of how a lot of this stuff works under the hood without doing like a full end-to-end, here's how Meterpreter works in one sort of epic session, because that's clearly a lot to digest. But I'm hoping that by seeing the traffic patterns and the general process of how commands are handled and how packets are pulled apart and all that sort of stuff, you can start to piece together the mechanics of Metasploit and Meterpreter and how they talk to each other, what the general protocol looks like, what the packets look like, how encryption is enabled, and all that sort of stuff. So anyway, hopefully you found that useful. If you didn't, you know, feel free to leave a comment. And I'll ignore it. So in future, I think the things that would be good to do on stream, if you guys and gals are interested in such a thing, would be to maybe add the tree view feature here so that we can actually see where the pivots are associated. And the other option would probably be supporting nested pivots. I think that would be good. Support nested pivots. I think the nested pivots is actually quite a big job. Quite a big job. From what I remember. I remember getting to that point and going, right, let's support nesting, and then wrote some stuff down on paper and went, not now, let's just let's just get the first version out the door. But anyway, I think that's useful, and this little bug fix will hopefully fix a point of pain for more people than just me. Okay, so with that in mind, that's an hour and a half down. I'm going to love you and leave you folks. What were we going to talk about briefly? What was it? Was there other things? Oh, we were going to talk about the PSXX stuff. How about we'll talk about how that works. You guys go and watch the video that was posted earlier on how PSXX works. As far as the WMI side is concerned, I don't actually know how the mechanics of WMI work. I know it's decom based and it uses the RPC service, but I don't know what messages go back and forth in order for a process to actually start. I have written code that uses WMI to launch processes, but the actual mechanics of what goes on behind the scenes in Windows land to make that work across different nodes, I honestly don't know. I would expect some kind of nasty decom call. It's worth diving deep at some point, but the PSXX stuff is clearly covered nicely, I think, by Dave Maloney's video that was kind of linked by somebody else earlier on in the stream. So go and watch that, because that's really, really useful, and Dave Maloney is a good bloke. Big thumbs up from me for Dave. And the other question was around climbing for those climbers in the room. There was a local climbing competition here in Brisbane called Boulder Fest, which myself and my eldest boy went and had a bit of fun at on the weekend. And yeah, he came 5th, which is fantastic. And I ended up coming 2nd in my category, which was a big fluke. But it was so much fun, like so much fun. If you guys haven't tried bouldering or even any form of rock climbing before, I highly recommend it. It's an awesome sport. The video, for those who weren't there earlier, thank you, Atwolf. There's the link provided by the legendary Atwolf. Go and have a watch of that video. It will explain, at least at a reasonably decent level of detail, how PSXX works. Okay. So, on that note, I'm going to go and chill out. Thanks again to everybody who continues to come and watch and listen to me fumble through whatever it is that I feel like fumbling through. Linked by Coffee Addicts. Yeah, cool. Thanks, Ace Bond. I'm glad you enjoyed it, buddy. So, yeah, thanks to everybody who comes along and continues to support me. Thank you again to all those people that have supported me on Patreon and Ko-fi and all those sorts of things. It really, really is appreciated, and it makes it much easier for me to continue doing this on a more regular basis. I will try and get another one of these done possibly next week, but work's pretty flat out at the moment. It's pretty tough. So, anyway, all good. Love your work. Thanks very much. Until next time, feel free to hit me up on Twitter, leave some comments on whatever videos, and I'll do my best to answer. Oh, and one other future stream possibly is getting Firefart's epic goddamn Go Buster PR landed. I am reading your code, by the way, Firefart. It's just there's a lot to it, and I want to make sure I understand it before I pull it in. So yeah, all good. All good. All right. Peace. Look after yourselves. I'll speak to you again soon. Ciao.